Here we are. Okay, so 11.6, we're still going on with area. The last formulas we're going to learn about for area, areas of circles, sectors, and segments. We know what a circle is, and we should know how to find the area of a circle. Everyone always mixes up area of a circle and circumference of a circle. So we know circumference of a circle is 2 pi r or pi d. Who remembers how to find the area of a circle? Simon.
Pi r squared.
You got it. Area equals pi r squared. And very similar to the circumference, you know how we always leave it in terms of pi for the circumference? Yeah. Same thing for area. We're going to leave it in terms of pi, meaning we don't put in 3.14. We leave the pi symbol. Right. So here it says, our first example, find the circumference of a circle whose area is 49 pi. So I'm looking at this and I see find the circumference of a circle. So immediately I'm going to write out the formula to find the circumference, which is C equals 2 pi r, or C equals pi d. Now, in order to find the circumference, do we all agree I need to know the radius? All right, so let's keep going. They're not giving us the radius, but they are saying the area of the same circle is 49 pi. Because they're now saying the area, I'm going to write out the area formula, where area equals pi r squared. And they're saying the area is 49 pi, so instead of A, I'm going to substitute in a 49 pi. And my goal is to solve for r. So I need to get r all by itself, so I'm going to divide by pi on both sides. And on both sides they cancel. So then I'm going to be left with 49 equals r squared. And to undo a square, we take the square root. Can a radius ever be negative? No, so the radius is just a positive 7. Square root of 49 is positive 7. Now that I know the radius, now I could go back into the circumference formula and plug in. So C equals 2 pi 7. And then we can multiply the 2 and the 7. So C equals 14 pi. Is it units squared for circumference? No, only area is units squared. All right, some new vocab words, sectors and segments. All right, the area of a sector. Well, first, before we talk about the area of a sector, let's talk about what a sector is. A sector, that's the blank right here, a sector of a circle is a region bounded by 2 radii and the arc of the circle. So if you basically have a central angle, it's the area in that central angle right there. It sort of looks like a slice of pizza. That's what a sector is. So just as the length of an arc is a fractional part of the circumference of a circle, the area of a sector is a fractional part of the area of a circle. So write that in and I'll explain this to you. So if we're given a circle, we know how to find the full area of a circle, right? Pi r squared. Right, but if I don't want the full area of the circle, I just want this sector. I just want this area right here that I shaded in yellow. Well, isn't this area in yellow a fractional part of the full circle? Right, so if I know what fractional part, let's say it's like 1/4 of the circle. If it's 1/4 of the circle, wouldn't it be 1/4 of the area? And that's what we're going to do. We'll find the full area and find the fractional part and then take that fractional part of the area. That's how we do it. So how? Here's a formula to add to your formula sheet. Area of a sector. You're going to do the measure of the arc over 360 times the area of the circle, which is pi r squared. All right, so we want to find the area of this sector. All right, remember the sector is the region between the two radii. And I'm going to write out the formula. Area of sector equals arc degree over 360 times the area of a circle, which is pi r squared. Now, isn't the central angle and the arc, aren't they the same degree measure? So if my central angle is 90, my arc is also 90. So the area of the sector is going to be 90 over 360 times pi, what's my radius? 2 squared. So let's simplify down. I'm 1/4 times 4 pi. What can I do with these 4s? 1/4 and 4 pi. Yeah, I could cross simplify them. They cancel out. So the area of this sector is just pi units squared. So what is that? About 3.14 units squared, right? Oh, no, this isn't the last formula. There's going to be more. Can we keep going? Everybody got this? All right, let's talk about a segment. A segment, very different than a line segment. A segment of a circle is different than a line segment. A segment of a circle is a region bound by a chord of the circle and its corresponding arc. So right here, obviously we have this chord. The segment is going to be the area between the chord and the arc. So that green area is the segment. Of the circle. Okay. So how do we find the area of a segment? I'm going to explain it to you. So let's say this is our diagram. I want to find that green area. There's no formula to just straight up find that green segment of a circle area. So what we're going to do is we would draw in radii. And when we draw in radii, I've now created a sector, right? When I draw in those radii. But the sector covers all of this area when I find the area of a sector. That's too much. Do you agree? So I'm going to find the area of the sector, but then I need to subtract something from it. Does anybody see, let me highlight it in pink. Does anybody see what this is that I just highlighted in pink? It's a triangle. So if I find the area of the sector, and I find the area of the triangle, and I subtract those two, wouldn't I just be left with that green area? That's what we want to do every time we want to find the area of a sector, a segment. So, formula for area of a segment, we're going to add this to our running list of formulas. We're going to do the area of the sector minus the area of the triangle. All right, ready to try out a problem? The circle below has a radius of 4. Find the area of the segment. So to find the area of a segment is equal to the area of the sector minus the area of the triangle. Who remembers how do I create the sector? Because I don't have a sector right now. Who remembers how do I create a sector?
You draw the radius.
You got it. I'm going to draw a radius from the center to A and a radius from the center to B. So then that gives me,
Our right triangle.
we don't know, oh yes, because of the 90 degrees. Very good. All right, so now we want the area of the sector. So now the area of the sector, remember, is arc degree. Oops. We're arc degree over 360 times pi r squared. Well, our arc degree is 90 over 360 times pi. Did they tell us what the radius is? Yeah, they told us the radius is 4. So times pi 4 squared. So we are 1/4 times 16 pi. I'm going to cross simplify these. So the area of the sector is 4 pi. Right. That is not my answer for the area of the segment. All right, so I found the full yellow. What do I need to find now? The what? The triangle. And guys, isn't the central angle and its arc, aren't they the same degree? So if the arc is 90, isn't that central angle 90? So this is really nice for us. So the area of a triangle is half base times height, which this works out for us because I have a right angle. One of the sides is the height. It's not always going to work out like that for us. So we're going to have half, the base is 4, the height is 4. Half of 4 is 2. 2 times 4 is 8. So we end up with 4 pi minus 8 units squared. That's the area of our segment. Are we ready to keep going? All right, so now we'll do problems that are a little bit more involved, not as straightforward. Everybody still copying? We're good? Okay. So now we got to create our own diagram. It says the measure of arc AB is 120 and the radius of the circle is 6. Find the area of the segment. Okay, so here we go. We're drawing our circle. So they're saying there is an arc AB, and that is 120 degrees. They want us to find the area of the segment. So the segment is going to be the chord that connects A to B. So the minute I see find the area of the segment, I'm going to now write out the formula. Area of a segment is equal to the area of the sector minus the area of the triangle. So we know this is our segment. I want to find that sort of slashed area. I need to create a sector. How do I create the sector? What must I draw? How do I create their sector? I have to draw something. Daniela? I'm sorry, draw the lines to what? From the center to? You got it. We got to draw lines from A and B to the center. So now remember, this whole yellow area ends up being our sector. How do we find the area of a sector? Who remembers the formula? Maya.
It's arc degree over 360 times pi r squared.
You got it. Arc degree over 360 times pi r squared. And the area of a triangle is base times height, half base times height. All right, do we agree this time our arc degree is 120? So now we're 120 over 360 times pi. They told us in the given information the radius of the circle is 6. So pi 6 squared. So I'm actually thinking a little bit strategically here. So I'm going to cancel out the zeros on the 120 minus 360 over 360, but I'm not going to simplify it any further. Does anybody know why I'm choosing not to simplify it any further? Why don't I bring down the 12 over 36 more? Because the 36 can cancel. Exactly, those 36s can cancel. Would it have been a problem if you brought it down further? No, it wouldn't have been a problem. So now we're at 12 pi for the area of the sector. All right, now we want to find the area of a triangle. Well, we know the central angle and its arc are the same. So if the arc's 120, the central angle is also 120. Hi.
Isn't Mia here?
Not in this class now. Oh, Mia, yes. I'm sorry. I'm thinking of my
Mia,
next class.
I'm testing your brother. Do you have his graphing calculator on you?
Yes.
Can I have it? Thank you. I'm sorry. We're going to do an AP exam and he doesn't have a calculator. He's like my sister. I'm sorry. I don't mean to interrupt. I'm really, really sorry.
You ruined this algebra.
I know. I'm ruining everything. I'm so
recording.
sorry.
No, you're good. It's fine. It's perfectly fine. You're not. I tried to be famous for years now, and it doesn't work for me.
Mia, he loves you. Okay.
At least you had it, right? Okay, let's keep going. So now we want to find the area of the triangle. We know if the central angle, if the arc's 120, the central angle is 120. But I need base and height. Can I say the base is 6 and the height is 6? No. What is the height made with? A right angle. 120 is definitely not a right angle. So what do I have to do? Any ideas? How am I going to find the height for this triangle? What should I do? Adrian?
Draw like the thingy from the middle to the corner.
The altitude. We want to draw an altitude. And now when I draw that altitude, what happens to that 120? It splits it into 60 and 60. It's like these triangles never go away, right? They just keep popping back up even when you think they have no place. So now we are dealing with a 30, 60, 90. Well, do we agree 2x equals 6? So if 2x is equal to 6, that means x has to be 3. The altitude is 3. What's across from the 60 going to be? 3 root 3, which means the other side is also 3 root 3. Do we agree? All right, so when it says half the base is not 3 root 3. What's the full base? 6 root 3. What's the height? 3. The height is 3. So I'm going to take half of 6 root 3 is 3 root 3, and then 3 root 3 times 3 is 9 root 3. So our answer is 12 pi minus 9 root 3. Can we keep going? Yes, no, maybe so. We're good. We got it. All right. So it says find the area of the annulus formed by two concentric circles with radii 6 and 9. All right, we need to know what this word annulus means because on the test, if it shows up, I won't be able to tell you. So what it is if you have a donut, not like a Boston cream, normal donut. right? The annulus is the area that you can frost. This yellow shaded area, that's the annulus. Okay, so we want to find the annulus, which is the yellow shaded area. And it says one circle has the radius of 6 and the other one has a radius of 9. Clearly the smaller circle should have the radius of 6, right? And the larger circle has the radius of 9. Any ideas on how I can just find the area of this yellow shaded region? Any guesses on what we should do? Oscar.
Find the area of the big circle and minus it by the small circle.
You got it. Area of the big circle minus the area of the small circle. So I'm going to say pi r1 squared minus pi r2 squared. So we're going to say 9 squared pi minus 6 squared pi. So we're 81 pi minus 36 pi. And then they both have a pi in them, so they're like terms. We can subtract them. And what are we going to end up with? 45 pi units squared. Can we keep going? All right, there are going to be a bunch of these types of problems. Do you see where it's like 3AB? There are definitely going to be problems like this on your test where it's like multi-step. So we want to find the area of the shaded part of each figure. Assume regular polygons. So if I'm assuming this quadrilateral is regular, what does that mean? It must be a? What's a regular four-sided figure? The only regular four-sided figure we've learned about. Square. Yes, Maya, a square. All right, so when it says assume regular polygons, that means it's a four-sided figure. It must be a square. So if it's a square, don't we know that all sides are congruent and all angles are 90 degrees? So I know the main figure here is a square. What are all these little loops? What are these called? Anybody know? Maya? Sectors. These loops are all sectors. How many sectors are they? 4. So for me to find the area of the shaded region, what I'm going to do is I'm going to find the area of the the area of the square minus 4 times the area of the sector. Why am I doing times 4? Because there are 4 sectors. How do we find the area of a square? What's the formula? Base times height or side squared. And then minus 4 times arc degree over 360 times pi r squared. Everybody okay with our game plan? Everybody understands why we're doing this? It makes sense. Okay, so then our side length is 10. And now our arc degree. Isn't our arc degree the same as the central angle? So if our central angle is 90, then our arc degree is also 90. So then I'm going to do 90 over 360 times pi. Now we have to figure out the radius. Well, if the whole length here is 10, wouldn't that be the diameter if we were making a full circle? So wouldn't the radius be 5 and 5? So then we're pi 5 squared. So we are 100 minus 4 times 1 over 4 times 25 pi. Actually, I don't need the parentheses because it's all multiplication. And now I can cancel out the 4's. So we have 100 minus 25 pi. Okay, for letter B, remember my directions. I said assume regular figures. That means equilateral, equiangular. So what kind of triangle does this have to be? An equilateral triangle. And remember, in an equilateral triangle, it's obviously also equiangular. So how many degrees is each angle in an equilateral triangle? 60. So we're 60, 60, 60. So now we're going to do, I want to find their shaded region. Oh, guys, I think my computer just froze.
Uh-oh. Oh no.
Give it a minute. Yep. Okay, I think it's working now. All right, so we want to find the shaded region, which is this yellow part right in here. Any ideas on how I can find just that shaded region? Mia? We're going to do the area of a triangle minus 3 times the area of the sector. altitude